This is the lesson for Chapter 9, Section 5, Completing the Square, day number 2. So for the first type of problem you're going to end up seeing, it's going to ask us to find the vertex of each parabola by completing the square. And so what we're going to end up doing is we're going to do the same thing we had done before. We're going to go ahead and complete the square, and it's going to end up, we're going to end up with an equation that's in this form here, y equals, and then y equals the sum of x plus h, and I'm going to go over what some of these variables represent, quantity squared plus k. And so h is just the number being added to x, the value that you get when you take half the b term, and that's going to be our h value. K is just a constant that it ends up equaling, and what we're looking for is the vertex, and the vertex is going to end up being those two values. However, the h value is always the opposite, and so if it were a plus h, then the vertex would be negative h comma k. So k will stay, whatever sign is here will be that value, but for h, the value of h, whatever the sign is here, it's always going to be the opposite of that value. And so let's take a look at our first problem here. So when we see one of these problems, the first thing we're going to end up doing is we're going to do the same thing we had done before, where when we're completing the square, we're going to bring the 28 to the other side of the equation. The difference is we're going to just keep y there. So it's just going to be y plus 28 equals x squared plus 2x. It's the same thing. We're completing the square. So we're just taking half the b term here, and whatever we get, in this case 1, we're going to square that answer, and we end up getting 1. So 1 is the number that we have to add to both sides. So I'm going to add 1 here and add 1 to the left-hand side. So what that gives me is y plus 29 equals x plus 1 quantity squared. So the next step is just bring this 29 back to the other side. And so when I bring it back to the other side, well, it's just a minus 29 now, and so we have y equals x plus 1 quantity squared minus 29. So it's in the form for the vertex formula. It's in the same form we have right here, and then I just write down what we have. So remember, it goes, whatever sign we have here is going to be our h term, and it's going to be the opposite of that. So it's going to be negative 1, and then whatever value we have here is just the same exact sign, negative 29. So that is the vertex. Let's take a look at our next problem here. And so on this one, we end up having to bring the 468 to the other side. So whenever you move something to the other side, it switches signs because we're doing an opposite operation to get it there. And so I've got y plus 468 equals, and then x squared plus 12x. So from here I just take half the b term, and then I square that answer, and that gives me 36. So that's the number, that's the important value to add, especially to the left-hand side here. So we have to add 36, we add 36. And so here's what we get. We have 468 and 36, well, that gives me 14, 10, and carry another 1, so 504. And then I have to have the y in there as well, equals x, and then this is going to end up factoring down to x plus 6 quantity squared. And so I go ahead and bring the 504 back to the other side. So you see how it switches signs when you bring it back, and I'm left with y equals x plus 6 quantity squared minus 504. So what's the answer? Well, the answer is this. We have negative 6, that's the h value. K is negative 504. So that is the vertex. So it's not a solution, it's where the graph ends up switching directions, where it either ends up starting to go up. In this case, it's a positive x squared, so it's going to end up doing this, and we're looking at this point right here. That value is the vertex. Let's take a look at some other problems. So the next set of directions is going to ask us to solve. And so what's difficult about these problems is that we have a term out in front of the x squared value. In this case it says a squared here, but remember our general form is this, ax squared plus bx plus c. So when I call it the a term, I'm talking about the number in front of the x squared value. So the first thing we're going to do is we're going to get rid of that a squared term. We're going to divide by 4 on both sides. And so when I do that, I'm left with a squared minus 2a equals 6. Now, I'm going to actually leave a little bit of a gap between the equal sign and that negative 2a. The reason why I do that is because I have to add a term there. So now I'm going to go ahead and complete the square. So that's the first step, is just to divide by that 4, and then it becomes a regular old problem. So I can go ahead and take half the b term, and I end up getting negative 1. And so then I take that value and I square it, and you should always get a positive because two negatives make a positive. So I'll add 1 to both sides. So I'm left with this, a squared minus, I'm going to go ahead and write the factored form instead, save myself a step here, a minus 1 quantity squared, because that's what a squared minus 2a plus 1 factors to, and then this all equals 7. So from this point, I can go ahead and take the square root. And so when I do that, that'll cancel out the squared symbol on the left-hand side, but I'm not going to be able to take the square root of 7, so I can write the answer as a minus 1 equals plus or minus the square root of 7. So I go ahead and add the 1 to all sides, and we have the exact form here. So this is the exact answers, because I have not simplified this. Well, if I want to go ahead and simplify to find out what that is, I can take the square root. And so I'll go ahead and do that here. And so on this calculator, what I'm going to do is I'm going to go ahead and press 1, and then plus, and then I press the square root button, which is right up here, and I enter 7, and that gives me one of the answers. So that's the 1 plus the square root of 7. I press the SD button, and that gives me a simplified form, or at least an approximate value. And so I can say I'll round to the hundredths place here, so I'll write that as 3.65. So you see, as I bring this back up, this 5 right here is large enough to round this equation, or this value, up. So I rounded it to 3.65 if I round to the hundredths place. And that's actually what they're asking me to do in this problem, because that's what it says right here, round to the nearest hundredths. And then I also have to set up another one. So it's going to be 1 minus. So I'll go ahead and clear that and press 1 minus, and then the square root button, and then enter the 7, and then press equals, and so that's what it's asking for. Again, that's the exact answer. I press the SD button, and that gives me the approximate. So again, I'm rounding to the hundredths place. So I look at this 5 right here, and that is big enough to round this up. So I'm going to end up changing that 4 to a 5. So it's going to be negative 1.65. And so those are the two solutions. So again, what that represents is where it crosses the x-axis, or in this case, the a-axis, they're calling it. So it's a negative 4a squared, so it's going to be a very steep, very narrow graph. And so in this case, they call this the a-axis. So this is the a-axis here, and so we end up having some sort of y-axis, some vertical axis over here. This point right here is represented by the 3.65. This negative 1.25, well, that is this value right here where it crosses the a-axis. Well, let's take a look at this next problem here. And here, first thing I want to do is bring this 15 to the other side. So I'll add it to both sides. So I'm left with 5n squared minus 3n equals, and then I end up getting 25. So I divide by 5. That's the first step you're going to do. Well, second step now you're going to do is you're going to get rid of that a term, the number in front of the n squared value this time. So when you divide by 5, every number gets divided by 5. So the problem with this one, what makes this one more difficult, is we've got a fraction, negative 3/5. But you've got a calculator, you can end up doing it. And so I'll rewrite that 5 there, n, and then this all equals 5. So remember the rule. You take half this term, so 3/5 times by negative 3/5 times by a half, or divided by 2. So that makes negative 3/10. You're squaring that number. You're taking negative 3/10 and you're squaring it. So when you square it, you can do this in your head. It makes 9/100. So that's what I need to add to both sides. And so the critical part is the right-hand side, because I have to add 9/900 to the 5. And what that gives me is this. I get 5 9/100. This all equals, and when I go ahead and factor this, whatever I get for half the b term is what the factored form is going to be. So it's that negative 3/10. So it's going to be n minus 3/10 quantity squared. So now I have to take the square root of this, and this is where it's a little bit tricky. So I'll go ahead and take the square root of 5 9/100. And so when I do that, I can go ahead and change this to a improper fraction. 5 times 100 plus 9 makes 509 hundredths. And this equals, and again I need to take the square root of that, and then I've got the n minus 3/10 quantity squared. So when I do this work, you should be able to take the square root of the denominator. And so I've got now plus or minus the square root of 509 all over 10, and then this all equals n minus 3/10. So at this stage, you know you're doing something right if the denominators are the same at this stage. So when I add the 3/10, you see how the denominators are the same, so my exact answer is this. It's 3 plus or minus the square root of 509 all over 10. So there it is. So now we want to find out what that is. So this is a good use of the calculator here. So I'll go ahead and pull up the calculator, clear the last one, and let's go ahead and substitute some numbers in there. So I've got a fraction here. So my calculator has the fraction button right here. So I'm going to press that, and I'm going to enter the numerator. And I'll just do the first part. So 3 plus, and then the square root button, 509, and then I have to toggle down to the denominator and enter 10. And I go ahead and do that work, and it gives me the exact form. And so I just press the SD button, and that'll give me the approximate. So 2.556. So I need to round to the hundredths place. So 6 is big enough to round that up. So I'm going to write that as 2.56. And then the next one, go ahead and clear that last one, and enter 1, or actually 3, minus, and then I need to do the fraction first. Let me clear that. So the fraction button, and then I need to do 3 minus the square root of, and then I have 509, and then I toggle down and I enter a 10, and then press the equal sign, and it gives me what I just entered in the exact form, and then I press SD, and it gives me the approximate. So negative 1.96. So again, that 6 is big enough to round the hundredths place to the next value higher. So negative 1.96. And so again, those are the solutions which represent the x-intercepts. Let's take a look at the last problem that we'll end up seeing here. And it is a problem in which we have to solve for the value of x. And so it's a rectangle here. The rectangle is shown at right, has an area of 56. So this is 56 meters squared. So what that means is, like, maybe one side was 7, one side's 8. 8 times 7 makes 56. Or, let's see here, we could do 14. 14 times by 4 is going to end up being 56 as well. So it could be any of these numbers. But what I want to do, in case this is one that doesn't quite work out, because again, you could go ahead and plug some values in here. Maybe if we said that x was, let's say, 4. 4 times 3 is 12 plus 2 ends up being 14, so that does end up working out, and we could end up finding that value. So this would end up being 4 in this case, but let's say we did not know what this was. Let's pretend, let's change the problem a little bit, and let's say this was, instead of 56, let's change it to 52. And so I'm going to go ahead and do that. So we're going to change this 6 here to a 2 to make it a little bit more challenging, so it doesn't end up working out as an exact value. And so let's go ahead and try it. So we take the 3x plus 2, and we're going to multiply it by x, and this is going to end up equaling 52. So I go ahead and distribute just like that, and I end up with this. A 3x squared plus 2x equals 52. And so first step is divide by the 3. So again, you want to get rid of that a term in front of the x squared value, and you end up with this. X squared plus 2/3 x equals, and then I've got 52/3. Don't change it to a mixed number now. Leave it as a improper fraction. It'll be easier at the end. So the next step, take half of the b term. Now when you do that, look for cross canceling. So you see how those cancel out, and you're just left with 1/3. If you wrote 2/6, well, again, that reduces down to 1/3. You're just going to have to reduce fractions later on, so you might as well reduce right now. So I take 1/3 and I square it, and that makes 1/9. And so that's what I'm adding to both sides. So I'll go ahead and add the 1/9 here and the 1/9 here. And so I need to, so that should be a 1/9. Let's fix that. So 1/9. And so I need to come up with a common denominator. I'll multiply by 3/3. So 3 times 52, that makes a 6, and that makes 15. So 156 plus 1 gives me 157. So I have 157 ninths. So I just added these numbers. I got 156 by 3 times 52. 3 times 3 is 9, so I could add the fractions together. On this side, it's the quantity squared. So whatever half the b term was right here, half the b term was 1/3. So 1/3 x, or x plus 1/3 squared, quantity squared. And so from this point, now I'm ready to take the square root to cancel out the squared symbol, do the same thing on this side. So at this stage, you know you're doing something right if, well, first of all, we should have the denominator being a perfect square. We do. So I've got x plus 1/3 equals plus or minus the square root of 157 thirds. So that's going to be a perfect square. The next thing you should see is that when you do the subtraction here, we should already have the same denominator, and we do. So our exact answer is -1 plus or minus the square root of 157 over 3. And so, well, I got the -1 because I'm taking away 1, and I just wrote it as one denominator. Now, we are dealing with distance. Distance and time. Distance and time problems. Those are the type that we'll see with quadratics in this class. And these should always have positive answers. And so we're going to end up coming up with a negative answer here with one of these. It's going to be this one. It's going to be the -1 minus the square root of 157 over 3. This is going to be a negative answer when we do this work. So this one is that extra answer that we're going to cross off. That's not going to work. The one that will work is this one, -1 plus the square root of 157. And it works because, well, the square root of 157 is going to be a pretty good sized number. Take away 1 is going to end up giving me a positive. So let's figure out what that is. So let's go ahead and use the calculator. And I've got -1. So let's get the fraction button up there. So fraction, -1. And then plus the square root of 157. And then I'll scroll down and enter a 3. And then I'll press equals. And you see how it gives me that answer. So that's correct. That's what I'm looking for. SD gives me the decimal form right there. So 3.84. I'll round to the nearest hundredth here. So the 3, this 3 here in the thousandths place is not big enough to round that up. So I'm just going to leave it as 3 and 84 hundredths. And these are meters. And so that's going to be our answer. And so we could have approximated this. You see how the square root of 157 is, let's see, pretty close to 169. And that's going to be about 13. And so it's a little bit smaller, so I can even be a little closer, because you see how it's between these two perfect squares. And so I could say maybe, oh, it's pretty close to 12.5. So -1 plus 12.5 gives me 11.5. And so 11.5 divided by 3. And so 3 goes into 11 and 5/10. Well, it goes into 11. We have 3 times with 2 left over. It goes into 25, about 8 times or so. You see, I got pretty close to what the approximate was. So just by doing that, you can end up coming up with a pretty close answer. So those are the types of problems you're going to see on tonight's assignment. Good luck.